morning, 4th grade. Today I wanted to talk to you about your math lesson for today and tomorrow. It's lesson 111 on circle graphs. So let's go ahead and read this lesson first. It says, we have studied pictographs, bar graphs, and line graphs. Another kind of graph is the circle graph. This is often called a pie graph because the circle is divided into sections that look like slices of a pie. We have an example here, and it says, use the information in this circle graph to answer these questions. So we've got 3 questions. Let's take a look, first of all, though, at the information that's included here in this circle graph. So it says, activities of 100 children at the park. We've got 18 are playing ball, 15 are eating, 20 are flying kites, 15 are skating, 19 are catching pollywogs. Then we've got a section that says other, which we'll come to in a moment. And we've got 12 that are hiking. So these are the activities of all these children here at the park. Now let's look at what our questions are. It says, how many children were there all together? Well, I could add up 12 plus 18 plus 15 plus 20 plus 15 plus 19, but this other category doesn't have a number in it, so I'm not sure how many are there. However, I have a huge hint here that hopefully you guys caught. What was the title of this pictograph? Of this pie graph here? That's right, activities of 100 children at the park. So the answer to A, how many children were there all together, is obviously, that's right, 100. It says, which activity were the most children doing? Now, we could go and we can look at this, okay, 18 is more than 12, 18 is more than 15, 20 is more than 18, 20 is more than 15, 20 is more than 19. And just by looking at how this pie graph is based out, I could guess that 20 flying kites is probably greater than whatever this number that is in the other. But let's go ahead and double check that here. So if I know I've got 100 children who are at the park, I can add up 12 plus 18 plus 15 plus 20 plus 15 plus 19 to figure out how many this other is. So when I add this up, I look in this and I go, I've got 10 here, I've got 17, 17 is 10 is 27, plus 2 is 29, 9 carry the 2, then I got 2, 3, 4, 5, 6, 7, 8, 9. So that other has how many kids in that section? That's right, just one child is here in the other section. So obviously flying kites is the thing that has the most children doing it. Now, for question C, how many children were not catching pollywogs? Well, I've got 19 catching pollywogs. So I need how many are not catching pollywogs. So I could take all these other numbers and try to count them out, or I can take my total number of children, 100, and subtract 19 from it. When I do that, I'll have the total that we're not catching pollywogs. So can I take 0 minus 9? No, I have to borrow. But I can't borrow from this 0, so I have to borrow all the way from this 1. Make that a 0. This becomes a 10, but I still need to subtract here. So this 10 becomes a 9, and this 0 becomes a 10. 10 minus 9 is 1. 9 minus 1 is 8. 0 minus nothing else is 0. So 81 were not catching pollywogs, while 19 were. And let's turn the page, and they'll explain out each of these here. It says, the title of the graph states there are 100 children. So that's pretty obvious. There are 100 children. The numbers inside each slice of pie show how many children were doing each activity. The largest number of children were flying kites. For C, only 19 of the 100 children were catching pollywogs. The rest were not. We subtract 19 from 100 and find that 81 children were not catching pollywogs. It's very important that you look carefully at the information that's provided in any sort of graph that you see, whether it's a pictograph, a bar graph, a line graph, or a pie graph. Look at the title as well as all the information provided. So it says here, use the information from the graph on the preceding page to the first page back here to answer these questions. So let's do these together. How many children were either hiking or skating? So let's go back over here and take a look at the hiking and skating section. Well, I've got 12 are hiking, and I've got 15 are skating. So how am I going to figure out how many children were either hiking or skating? That's right, I need to add them together. So I'm going to take 12 hiking and 15 skating and add them up 2 plus 5 is 7. 1 plus 1 is, that's right, 2. 27 were either hiking or skating. All right, B. How many more children were flying kites than were catching pollywogs? Very important wording here. How many more means we're going to do what, class? That's right. We're going to subtract. So I need to know how many more are flying kites than catching pollywogs. So if I've got 20 that are flying kites, 19 are catching pollywogs, I need to subtract 20 minus 19, and I get the answer is, that's right, 1. One more child was flying kites than catching pollywogs. Final question, C. What number should be in the section named Other? Oh, no, we already figured this out before. Do you remember how we did that? We had to add up all of the numbers, 12 plus 18 plus 15 plus 20 plus 15 plus 19, and then subtract it from 100. And how many did we have find there in that other category? That's right. It was 1. Now remember, if you're not careful with graphs, you can end up finding the wrong information because letter B asked for how many more kids are flying kites than catching pollywogs. If we're not careful, I might take flying kites and add it to pollywogs. Or if I'm not careful, I may take flying kites and subtract it from skating if I don't look at the category that they're asking about. So not only do I need to look carefully to see if we're subtracting or adding, but I also need to look carefully at what category they're wanting you to pull information from. There's one more pictograph, pie graph here that we're going to go look at, and this is how Dan spent his day. We're going to use the information here to answer questions 1 through 3. So first of all, it says, what is the total number of hours shown in the graph? Well, I could add up all of these. I really could, but there's an easier way. You guys think of an easier way looking at the title, how Dan spent his day. How many hours are in a day? That's right, 24. So if this pie graph is showing us how Dan spent his day, then the number of hours are going to be how many? That's right, 24. So for 1, the total number of hours shown in the graph is 24. And I could add 9 plus 6 plus 1 plus 2 plus 3 plus 1 plus 2 and get 24. Or if I look carefully at this title, I can find the shortcut. All right, 2. What fraction of Dan's day was spent watching TV? Now, this is important here that we think about this carefully. We know that he spends how much time watching TV? That's right, 1 hour. So 1 hour can be the numerator of a fraction. What should be the denominator of our fraction? Should I say it's 1, 2, 3, 4, 5, 6, 7, because that's how many this is broken up into? I could if these were evenly broken up, but they're not. So once again, how many hours were total shown? That's right, 24, which means the fraction he spent watching TV is going to have a denominator of 24 total hours. And the answer, our numerator, is going to be how many of those are watching TV, which is, that's right, 1. Okay, final question. If Dan's school starts at 8:30 a.m., what time does it end? Okay, we've got a time problem to figure out. So we've got starting at 8:30, and we need to know what time it ends. How could we figure this out? Good idea. We can look at how many hours he spends at school and count to see what time his school would end. So if he spends 6 hours at school, we need 6 hours before or after 8:30. That's right, before 8:30. So I need to go 8:30 and count ahead 6. 9:30, 10:30, 11:30, 12:30, 1:30, 2:30. That's what time his school ends. Remember, when you're working with graphs, whether it be a bar graph, line graph, pictograph, or in this case, a pie graph, look carefully at the title. It gives you important information. Look carefully at each of the categories, how they're labeled, and what amount is in them in order to help you do well with graphs. Have a great rest of the day working on the rest of your math paper.